Let's try to solve the exercise number 5 for the part B program, C program. In this exercise, we are supposed to find the real number is prime or not. So this is the question. So we have to find a number is prime or not. Before we try to find that thing, let's try to consider. So a prime number are those that have only two factors, that is 1 and x. There are, in other words, no other numbers can divide it perfectly. So if you take the 5 here, so 5 can be divided by 5, you know very well, 1 divides 5. But if you look at the other numbers, 2 cannot divide it because 2 divides it 2 times and 1 is a repeater. 3 divides 1 time and 1 is a repeater. 4 divides 1 time but 1 is a repeater. But if you take the 5, 5 divides itself perfectly without giving out any remainder. So that means to say that when you have a number, if this number, any number for that, n, is divisible by 1 and itself, that means to say that if n is a number, I am taking a general number n, and if it is divisible by n and itself, so only two divisors are there, in that case it is called as a prime number. If there are any other devices are there, then we say that as a composite number. So you must understand very important thing that whenever we say that a number is a prime number, the prime number must be always greater than 1. So any number greater than 1, because you know very well 1 divides itself. 1 is not considered as a prime number. No other devices are there, but still 1 is not considered as the prime number. It is always the greater than 1. So now let's go back and let's look at the logic, how we can develop this logic in. So I have the code block with me. I'm going to go to the file menu of this code block, and I'm going to say new, and I will say new. I'm going to say file because I want to develop a C program. I'm going to say new file, and I will select C++ source code because just developing a C code. Then I'm going to click on OK. It is going to show me a dialog box. Let me click on next, and I'm going to say that I want to develop a C program. Let's go next, and here you are supposed to give the location where you want to store your files. Now generally your teacher will tell you that you have to store in D drive or C drive or Z drive, whichever drive they are saying that. Click on this ellipsis here, button with the ellipsis, and go to the location where you really want to save the file. Now I have a location called as sample, let me say, wherein I am going to say it. If it is not a different location, go to the different location and then click on my PC. Go to the exact location where you want to save it, and then you are good. Let me give a name for this one as prime. You don't have to specify the extension .c. Even if you specify, there is not a problem, because the code block will add the extension for it, because you have already said that it is a C program. It's going to add and it's going to create a file with the name prime C. You notice that it has created a file with the name prime C. Automatically it will add the extension as .c. You don't need to bother about that. Okay. Then if when you type it, if the things are not very, if the things are very small, you can hold the control, and on your mouse there is a wheel. You can increase or decrease move the mouse wheel on your mouse. You have this mouse wheel. Press down the control button, hold it down, press the control button down, and then start moving the mouse button. You can increase or decrease, or you can zoom in or zoom out, so that it is comfortable to your eyes. Now the question is, how do I go about solving this problem of the prime numbers? So I am given a number, say, let's say I am given a number 10, let's say, no, 15, 10. I want to check whether the given number is prime or not. You know very well, whether it is a prime or composite, 1 will always divide 10. So there is no point in checking for whether 1 divides it or not. 1 will divide any natural number. Then comes the 2. Whether this one. Then take the number 10, divide it by 2 and check whether it divides. Now in this case it divides the 10, then it's all over. There are one more number apart from 1 and 10 itself. There is one other number 2 which can divide 10 without remaining or without giving any remainder. That means this is a composite number. Now let me take the number 11. I am not going to check whether 1 will divide 11 or not. 1 will divide it. Okay. So let's go ahead with the second number, that is the number 2. So will 2 divides 11? No, because 2 will divide 5 times and 1 will be the remainder. Let's go to the next number, that is 11. I'll take the next number, and that is 3. Whether 3 divides 11? No, 3 will divide 3 times 9 and 2 will be the remainder. Let's go to the next number, whether 4 divides 11. You know very well, 4 divides 2 times and 3 will be the remainder. Let's go and let me take this 11 and let me divide it by 5. Whether 5 divides it, and 5 divides it 2 times and 1 will be the remainder. Let's go to the 6 here. Let me go to the 6. 11 divided by 6. Okay, so I'm going to go with 11 divided by 6, and whether 6 divides the 11, you know very well. Now 6 cannot divide 11 because it divides once and you get the remainder. Then how many numbers we have to go? We have to go with the 7, 8, 9 up to 11. Okay. You know very well 11 will divide itself, so there is no point in checking whether 11 will divide 11. 11 has to divide itself without any remainder. Now the question is, do we have to go and start checking for 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on up to 10? Is there a shortcut than this? Now if you take anything for that matter, suppose if you take anything, you can divide it by half. That's the first division. When you take anything, you can divide this one by half. Okay, and you can divide it by 1/4 and so on and so forth. 1/4 anything you can divide for that matter. You can divide anything. That is like okay, so you can divide it like this. You can divide it like this. You can go on dividing it, but the first division is half. Okay. Now what is half of 11? So half of 11 is 5.5. So this, if you divide it by 2, this is going to be 5.5. So I'll take up to 5. So I'll check whether 5 divides it. If the 5 is not dividing the 11, then I assume that it is not a prime number. Why not 6? Remember, if the 5 can divide it, 6 cannot divide it. You take any number. You take for that matter, you take one more number, 21. What is half of it? 10. Okay. You know very well. 10.5. If you divide this 22 by 2, you know very well the 10.5 is the answer you are going to get. Now if the 10 is not dividing 21, I don't have to check for 11, because 10 will divide it by at least 2 times. 11 cannot divide it, 12 cannot divide it, 13 cannot divide it. You just check the logic. 14 cannot divide it. Anything that is above the half the limit. So you take any number for that matter. anything about this half limit. So the one that you can divide it is by half. So what is this? So I just removed everything. Let me start over again. So anything that you take, okay, you can divide it by half. That's the first division. If you are not able to divide it by half, you will there will be a remainder. That's it. It's not possible. So if you take any number for that matter, suppose if you take 50, what is the last number that you can think of dividing it? Half of it, that is 25. If the 25 up to 25 nothing is dividing it, 26 you don't have to divide it. I'll tell you one more logic why you need that is not required. Let me take this 11 itself, and you know very well, if you divide this 11 by 2, if you divide this 11 by 2, you know very well this is going to be 5.5. I'll take this whole number 5. Okay. Now you know, you start dividing it by 2. Whether 2 divides 11, no. 3 divides 11, no. 4 divides 11, no. 5 divides 11, no. 6 divides 11, no. The answer is, if 6 is dividing a number, then 2 can divide 6 itself. You know very well, 2 is a multiple. Okay. So 6 is a multiple of 2. 3 can also divide 6. What do I mean by saying that? You take this number 24. Okay. You know very well, okay, 6 divides it. Yes, is it not? But if you reduce this number, if you divide this 6 by 2, okay, so this will be the remainder will be 3. Again you divide it by the reduce this number by 12. Then you notice that 2 actually divides it. Anything like, if you, in other words, any multiples of this number will divide it. Now suppose if you take 8 here, if 8, sorry, it's not 4, the number should have been 8. If 8 divides it, then you know very well 4 itself will divide 8. If 8 divides it, 4 must divide the given number. If you have a number called as x here, and if this x is divisible by 8, naturally 4 will divide this 8. The reason is 4 can divide 8 itself. Naturally any multiples of 8, 4 can divide it. So that's the reason. That's the other reason why we say that we don't have to go beyond that one. Now the next question is there still a shortcut? The answer is there. There is still a shortcut if you are a good mathematician. If you take a number, okay, like 25, you know very well half of this 25 is going to be divided by 2. Half of it is going to be 12. You know very well. So you have to start from dividing 25, whether 2 divides 25, whether 3 divides 25, whether 4 divides 25, 5 divides 25, and so on, up to, you have to go up to 12 to check whether the given number is prime or not. The question is, you don't need to go up to that part. So what is the, then you are supposed to do it now. Okay, what is this? Suppose if you take the square root of 25, suppose if you take the square root of 25, the answer is going to be 5. So you just have to check, mathematically you can prove that. You can just check whether 2 divides it, 3 divides it, 4 divides it, 5 divides it. You don't need to check whether 6 divides it or 7 divides it. You don't have to go up to 12. This was 12. I think I deleted it. So let me put it here. This was 12. So you don't have to go from 6 to 12. There is no need to check whether 6 divides, 7 divides or 8 divides. Up to 5, 2, 3, 4, 5, if they are not dividing the number, then you can say that remaining numbers will not divide it. 6, 7, 8, 9, 10 up to 12 will not divide it. It is a prime. So just by taking 2, 3, 4, 5, division by 2, 3, 4, 5, you can just say that whether the given number is prime or not. But we generally don't use this technique. Okay, what is the reason? In computers we don't generally go up to square root of a number, even though it is a very less. You just take 144 or kind of this thing. Okay. So 144, half of it is going to be 72. So you will have to check to in our normal way, half cut if you just say. So that means you have to say 2, 3, 4, 5, 6 up to 7 up to 72 and check and say that whether the given number is prime or not. So very large number, but you know very well square root of that is going to be 12. So within 12 numbers, that is whether 2 divides it, 3 divides it, 4 divides it, 5 divides it and so on. If 12 is not dividing it, then it is a prime. You don't need to check for the remaining number. So your space, that is a number of divisions, will drastically reduce if the number is higher, but we don't go for that calculation. The reason is finding a square root. Actually, how do you find a square root of a number? Finding a square root is a critically long process. It takes it's a laborious process, and it takes a lot of CPU cycles, and it is also a floating point calculation, which is again a costly operation. So we don't generally prefer taking the square root. But if you are using a square root, that means you are a very learned person and you want to do it efficiently. So that's the idea. I'm going to stick on with the half cut. That is any number that is given to me. Okay. So if the number that is given to me is 100, I go half of it. That is what is a half cut means. I go half of it. That is 100 divided by 2. That is going to be 50. So I will check whether 2 divides 100, 3 divides 100, 4 divides 100 up to 50. Up to 50, if none of the number divides 100, then I say 100 is a prime number. But in between, if any number divides it, like if 2 divides 100 without giving any remainder, then I simply say that the number is prime. So the first violation, what is the meaning of first violation is you know that a number is prime if it one and itself is dividing it. If any other number is dividing it, then it is not a prime. So that means you have to first find one culprit. Okay. So you are given, just to say you are given a number, say 43. If you find one culprit, I don't know whichever is, let's say that culprit is I. If you find one culprit I which will divide 43, the minute you find apart from 1 and itself, that is 1 and 43, in between if any one of them divides that 43, that means immediately you say that it is a prime number. You don't have to check for that. So for example, I'll give you a number 10, very simple number. Okay. Let me take this. So I divide it by 2. You know very well 2 divides 10. That's the end of it. So that means 1 divides 10. 10 itself will divide 10. But you have in between you have one more number 2 that divides 10. That means it is not a prime number. I don't have to check for 3. I don't have to check for 4. I don't have to check for 5, because even if I get at least one number that divides 10, that is violation. So what is the meaning of saying violation? Violation is, here they have said that the number 1 and itself must divide it. No other number must divide it. In this case what happened is, there was 2 that divides 10. That means a violation. There is one other more apart from 1 and itself. There is one other number that can divide the given number. That means to say that it is not a prime number. So let's go ahead and let's build this one. To do the input output operation, I need a standard input output. So I'm going to say std io.h. So I have this one. Okay. Then I have one more. I'm going to say include. I need console input output. Now this is not really required, but if you are using your old favorite Turbo C, which is outdated, you need to use that thing. Now the main, generally, see, whenever you run a program, okay, once the program executes, once the program completes, it is supposed to tell the operating system, that is your Windows that you have it here. So it is supposed to tell the Windows or Linux or anything that I've successfully completed. So it is like when a task is given to you, if you complete it, you just tell your teacher or tell somebody else that I completed my work or I could not complete it. So something like that. So even when somebody is teaching you, if you don't understand, you just raise your hand and say that no, I didn't get what you said, or I completed. Or so people will say okay, I got it, whatever you said I got it. So that okay is that word that indicates that you have understood or you have completed it. In the same way, the program that you are writing, the prime program that you are running, when it completes, you have to tell the operating system that I have completed my work. That's a good person, you can say it. But as a bad person, you can say that I am not going to tell you anything. I complete the task and go. No, there are many students in the class who quietly come and quietly go. But there are a few exceptional students who, when they enter, they want to make a scene, and when they want to go, when they are going out, they want to make a scene that they were there, they are going out. Okay, there are two types of people are there. So I will go with the polite people. So I'm going to say that this particular program will not return anything. So what is it returning? You can say my program is returning an integer number. Generally it should be an integer, saying that whether a program was successfully completed, whether a program completed with an error, or so on so forth, exception and so on so forth. Generally you give an integer number, 1, -1, 0, something of that type. But I'm going to say my program will return void. What is void? Void means nothing. In other simple word, my program, when it completes, will not return anything to the operating system. So that's simple as that. So in other words, I'm telling the operating system, don't expect me to give you anything in return. I will complete my work and quietly I go away. Okay. And you know very well, any C program will start with main. Okay, and there is a open and closing flower bracket. You have to do that thing. So let me give some space over here. Now I need to store the given number, so I'm going to say int, that is an integer number. I'll take integer number n as my number. Okay, and I assume that the given number is a prime number. So p equal to 1 means it is my assumption that whatever number you give, I assume. So I'm a bit optimistic, and I assume that whatever number you give is a prime number. If my assumption is false, if I find that what number you have given is not a prime, and then I'm going to set the value as 0. 0 means it is not a prime number. 1 means it is a prime number. This is for my reference. So I assume that what number you have given to me is a prime number. Apart from that, I need a looping variable that will increase the value of the devices. Now what do I mean by saying that is, so suppose if your number 10 is given to you, and then I have to divide this 10 by continuously by 2, then 3, then 4, then 5, then 6. That means there must be something that will take care of these numbers 2, 3, 4, 5, 6 and so on and so forth. That is taken care by this I will tell you, I will give takes the value 2, I will take the value 3, I will take the value 4, 5, 6, 7, 8 and so on and so forth. So that I is meant for that, which will continuously take new values. So that being done, let's go ahead and let's see if you, I'm not going to use this one. If you are using a fan of Turbo C, you generally use a clear screen. Okay, I will not do it because it's not really required. In this ID you don't need to write it, you can reduce that line of code. Now I'm going to use a printf because I want to show something to the user. So I'm going to say printf, and I'm going to say, okay, enter, where is this? Enter a number. So I'm going to say enter a number. So that is done. Then I'm going to read the value for n. So I'm going to say scanf, because n is a integer. So what I have done here is I've said n is of type integer. So n is of type integer. In that case, what I'm supposed to do is I'm supposed to use percentage D here, and naturally I have to give the address of n. So these are all C way of doing it. So I'm giving what is this? So I'm giving a so let me click on this plus now. I have given the address of en. So that is being done. So let me, by the way, let me zoom in for you so that you can see that on your screen. Okay. Now I'm going to check whether the given number is less than 2. You know very well there is a condition that says that if the given number, let me go over here, where is this one, not this one, if this number must be greater than 1, that means it must be at least 2. If a given number is less than say 2, then my assumption that the given number is a prime, this assumption is false. So I can straight away write here, maybe you can write p equal to 0 here. It's not a syntax error. Okay. But also you can write it in the next line. It's up to you. Okay. So p is 0. What is the meaning of saying p is 0? That given number is not a prime number. So you assumed that whatever number that was given to you was a prime number, but you find that what the person has typed is less than 2, then it cannot be a prime number. There is no point in checking for it for the prime number. So if the given number is not a number which is less than 2, then you start dividing it by 2, dividing it by 3, dividing it by 4, dividing it by 5. How much? You know, half cut. What is half cut? 10 divided by 2. What is the 10 divided by 2? Is 5. So you go up to half cut. So if the given number is not less than 2, then you start from 2, 3, 4, 5, 6. Oh, keep on dividing it from 2, next time 3, next time 4, next time 5, next time. How long? Up to how long? Up to the number becomes half cut, that is half of the number. So given number is where is it gone? Let me do this one. So given number 10, okay, half of it, that is by 2, half of it is 5. So keep on dividing is this number by 2, by 3, by 4, by 5, by 6, no 6 there, by 4, 5 is the end of it. Suppose if you are given a number 33, then what is the half of 33? Is 11. So you start dividing it by 2, whether 2 divides it, 3 divides it, 4 divides it, 5 divides it, of 6 and so on, up to 11, that is half cut. Up to half cut you go, and then if it is not dividing it, you say that beyond 11, that is 12, 13, 14, you don't check it. If up to 11, if the number is not divisible, then you immediately say that it is a prime number. Otherwise you say that it is not a prime number. So I think when I did something, this line simply went to the other side. Sorry about that. So it was here. This is the right place for it. Simply went to the other side. So I go up to half of it, then I use the flower bracket. Let's say, what is that you are doing? So you take from 2, you take it from 3, 4, 5, 6, 7, 8. So you start from 2, next time 3, next time 4, next time 5, and so on. What is that you are doing it? Every time you take this number and you try to divide it by this I. So I is 2 now. Next time I will become 3, next time I become 4, 5, 6, and so on. So you start dividing the number by I and check whether it is perfectly dividing it. What is the meaning of saying perfectly dividing it? If you get the remainder as 0. So for example, if you take this number, let's take this number 10, and you divide this number 10 by 2, okay, then there is no remainder. But what about this one, 11? If you divide it by 2, then you know very well there is going to be remainder. Suppose when you divide a number by 10, if there is no remainder, what does that mean? 2 will perfectly divide 10. That means given number cannot be a prime. Why? Because the given number is 10 here, and if it is a prime, 1 and 10 must only divide itself. Then you call it as a prime number. But you find that there is one more number 2 that can also divide 10 without giving any remainder. So that means this is a composite number. So simple as that. Okay, so if the given number, if the I divides, remember what is the meaning of saying I divides? So if I divides, when I is 2, when I is 3, when I is 4, up to half cut. So up to half cut, if any of the number divides it, so remember I will take different values. So if any of them divides it, then our assumption that the given number is prime is false, because apart from 1 and itself, there is one other number that divides 5. So that is not a prime number. So you say that it is not a prime number. Do I have to check for the other number? For now, let's say given number is 5, and how many numbers you have to check? You have to check whether 2 divides it, 3 divides it, 4 divides it, 5 divides it. Above 5 I don't have to do it, because you know last thing is half cut. Half of it is 5. So up to half you have to check it. Now when I know that 2 divides it, 2 divides 10, do I have to check for the remaining 3, 4, 5? No, because when you find some number that is already dividing the given number, that's a violation. It is a composite number. It cannot be a prime number. So suppose you have 24 here, or say 27 here. Now 2 is not dividing it, but so can I say that it is a prime number? No, I have to go to the next number. Whether 3 divides it? Yes, 3 will divide it. Then do I have to check whether 4 divides it? Not required. You got an exception here saying that there is one other number apart from 1 and 27 itself. You get one more number that can divide 27. That means it's not a prime number. So the minute you find an exception, there is no point in going ahead. So I'm going to write a word break here. What is the meaning of saying break here? You don't continue taking the next number. So first time I is 2, next time I is 3, next time I is 4, and so on. So the minute you find an exception, don't repeat this one. Just come out of this. This is an exception. We got one number that is dividing the given number, and we just come out of this for loop. And finally, now we are going to check whether our initial assumption is true. So if our initial assumption is true, that means what was my initial assumption? Initial assumption is given that the given number is prime. If it is a prime number, then you print and you say that percentage D is a prime number. Okay, what is this percentage? Percentage is n. So what is the number that you have read? Number that you have read is n. So you say that whatever n is 5, n is 10, n is 27, n is 100, whatever that number that was given to me by the user is a prime number. Else, remember this flower bracket is not really required. I am just putting it for brevity. Then I am going to say is not a prime number, and which is this number that I am talking about, n. I am going to put the semicolon here. I have to put the semicolon here. Remember, I have my closing bracket of my main. So I will just reduce it so you can see that. So closing bracket of main is also there. So this is my program. Okay, done. Now I will have to see there is options over here. We'll just zoom it here. You have an option. This is to build. That means it will compile the program. It is to run the program. The next option is build and run. That means it is going to build the program and run the program. But before you do it, you must always remember this keyboard shortcut. And what is this keyboard shortcut? Is CTRL plus CS. This is to save. Okay, save the program. You can also, if you don't forget that thing, you just come here and save all. It's going to save the program. Okay, see, the minute you make some changes, you see, you just look at this part here, just concentrate at this part. So the minute I make some changes here, okay, you notice I deleted something. You notice a star here. Star means it is dirtied, means some changes has been made. Yeah, I'm going to press Control yes. You can't see that. Okay, that means I'm saving it. The minute I save it, it goes. So if you find a star between the name of the file, that means the file is dirty. It is not saved. Save it and then compile it. Always remember that. Otherwise, it will not, whatever new things that you typed will not be taken up. You have to save it, then only it will compile it. Then which one are you going to use it? I'm going to click on this one, build and run. So I'm going to click on this build and run. It will build it. If there is any error, it's going to show you at this point. Okay, so you notice that there is an error that says that there must be a semicolon before that one. Okay, so where is this semicolon? So semicolon is here. So as I talk, okay, now this for loop is not completed. Why it is not completed? I went and I said that I start from I is equal to 2, and I said I half cut. How to increment this one? I have to say, how do I get the next number? I'm going to say I plus plus. So I is 2. Next time I is plus plus. I is equal to I plus 1. That is I must be 3. Next time I must be 4. Next time I must be 5. So how do you say that increment that is there? You have to say like this. So you can just double click on this red colored one. It's going to take you directly over here, and you will notice that it will also highlight at this corner. It is going to highlight and say that there is an error at this particular stage. Make the correction, and when you make the correction, you know very well it is dirtied. You see that star there. Control S to save it. Okay, and then build and run it. Okay. If everything is perfect, you will see that the program is running. Okay, you will see a program that is running with the output, and you say whatever you want. You can say that thing. So enter a number. Okay, I'm going to say the number is 5. I press enter, and you notice that 5 is a prime number. So is it a prime number? In the notice over here, 5 is a prime number, so it is a prime number. So your program is over. Press any key to continue. Your program will continue. Again, I'm going to run one more program. Again, build and run. When I run it, I'm going to say given number is 10. Press enter. 10 is not a prime number. You notice only these two lines. 10 is not a prime number. It's going to tell you what is the time it took for execution and so on. Now you may say that, oh, what is this? Why it is showing that thing? Come to the 5th semester, I think 5th or 6th semester, wherein you will study about the efficiency of the algorithm, execution time, and so on and so forth. You will study about why that is very important in writing the program later in your semesters, not this semester. In the coming semester, you will learn about algorithm, the efficiency of the algorithm. That's very important for a programmer. That's all in this short video. We'll meet again in the next class. Thank you.